Welcome to this video. My name is Rajveer. I'm the founder of Code and Compile, and in this video we're going to talk about Control-X I/O. If you haven't seen my last videos in Control-X Core, I highly recommend you to watch those, because in those videos I have explained what is a Control-X Core, which you see on my screen. But in today's video we will talk about some extra hardware modules. In this hardware modules we have a bus coupler and digital input and digital output. In the last videos I have shown how you can write a PLC program, but I was using internal variables. But in this video we're going to use external voltages and external IOs and connect that to Control-X Core. So in case if you have physical input and outputs in your applications, you can connect that easily via EtherCAT. So let's see what do we have in this video. So we're going to talk slightly about these hardware modules. So we have a bus coupler, which couples the signal between digital input terminal and digital output terminals with Control-X Core. And in this digital input terminals, we have 16 channel inputs, which is detecting binary voltage, 24 volt. And in digital output terminals, it supplies 24 volts to the load. So it is one wire technology. You just have to plug in the single wire. And it has 16 channels, and with reverse polarity protection for the input channel, and for the output you have a load capacity of 0.5 ampere. So this was a little bit information about this hardware module. The important part is how we can configure these modules in our Control-X Core. So we jump to that now. But the first step before we jump to the software part is how to connect these hardware modules to Control-X Core. What is the interface? Let's watch a small video which I made before recording this video to show you how this can be done. So it's a time-lapse video. Let's have a look together. So in this video you will see it at the moment I have Control-X Core right now on my trainer. Okay, and then I bring in my bus coupler, and in this bus coupler you can see there are two Ethernet ports. On the top is for input and on the bottom is for the output. And this comes with a side cover which you see, and which I will remove this cover. And when I remove this cover, you will see there is a bus there. And this is used to supply voltage to the digital input and output terminals or output modules. So I will show you that here. So you just slide in there, and here comes my digital input module, which is having a 16 channel. And here you can notice I connect this bus like this. So they are connected together by this bus, and comes another digital output module which is also connected in a similar way. So once you connect that, you have to plug in your IO terminals, and these terminals are already connected to one of my input devices, just some toggle switches, which is supplying 24 volts to this device. And then we connect this if you notice this plate back to the extreme right side, which prevent contamination or short circuit to your devices, so extra security. So once you plug in your modules, all you have to do is, next step is to connect the power. So in this case, we are using 24 volt supply to power up your devices. First, we supply 24 volts to Control-X Core, and then we supply to our bus coupler, which supplies this 24 volts to this digital input and output terminals internally. So once everything is checked, you have to check every connection is tightened, and then just apply the power. And once you supply the power, you will see the status on your Control-X Core and also the status on your bus coupler and digital IO terminals. So the blue status means it is not configured yet. Okay, so we will see what will happen when it's configured. So to connect this Control-X Core with this coupler, you will notice I'm using an Ethernet cable, which goes to the input port of my bus coupler, and the second cable goes to Control-X Core into the central Ethernet port. And now once everything works fine, you can see I can turn on my inputs, and I can see a green LED status on my Control-X I/O. Alright, this was a small video, time-lapse video to talk about how hardware can be connected together. Now we jump to the software part, which is the interesting part, how to read the IOs in our Control-X Core. So let's see what do we have in the next slide. Configuration of Control-X I/O. Now this configuration is done with the help of an app which is called EtherCAT Master, and this app you can buy from Control-X Store, and once you install this app you will be able to configure your Control-X I/O. How to do that? Let's look at together. So I will open this one here, and this is my Control-X Core. You know that this is how you log into your device. If you haven't seen this part before, just check out my first video. Otherwise, once your app is installed, you will see here it says EtherCAT, but it says it's not configured yet because we have to do the configuration. In this case, you just go inside this app and then you will go to the plus icon and it says, do you want to add EtherGate master? Yes, I want to do that. And the name, you can give any name, or by default, EtherCAT master is fine for me. Port is XF50 by default, and click on OK. And once you do that, it says your port is created. And if I go inside this EtherGate master, I can see I have my operational state. This is the initialization, pre-operational, safe operation, and operation. So this is at the moment at operational state. But if you see, the status is red. The status is red because I haven't defined the topology yet. So it says the topology is not defined, it's not okay, slave is in master state, is also not in the master state, bus is also not running. So we have to do the configuration before we can actually use it. To do that, you will see a small icon here, ControlX IO Engineering. This will help us to configure this device. So let's click on that and it will open my ControlX IO Engineering. Now here you can see I've already defined some configuration, but since in this video we start from scratch, so I will delete everything. And once you start ControlX IO Engineering, you can click on New, and I will click on, let's say, Empty Project. Okay. So this is my empty project. Now I have to add a device. So now, because we are talking about ControlX IO, we have to add ControlX IO configuration, not the core. Okay, IO configuration, select, and you will see your device has been added. Now the configuration, in this configuration, the communication between ControlX Core and ControlX IO is by EtherCAT. So we have to add that as well. So you can click on Add Device and you will see we have already defined a field bus, EtherCAT master, EtherCAT master. So we will add this in our device. So this is added. Another very important thing you have to do is once you're starting the project from scratch, you have to define the communication port. So there's the communication settings here. So I can click on that, and here I have to enter the communication, the IP address of my ControlX Core, because that acts as EtherCAT master. Okay, so I will put my IP address, which is this one, and click on test. So this is tested, working fine, click on OK. And now I can go here and I can see scan for devices. So once I scan for devices, I can see my devices are found by ControlX Core because we have coupled that with this Ethernet cable. So once you find your devices, you can see here we have a bus coupler, which we connected. We have digital input terminals and digital output terminals. All are available here. What you have to do is click on this button. It says insert all newly scanned devices. And once you do that, it's available in the project. So this is on online and this is now in the project. Click apply and click OK. So you have your devices here. Perfect. So if you double click on this one, you can see that your information about your digital input terminal, process data, IO mapping, and information. All right, we don't have to do much here because this is just the configuration. We will do the mapping when we talk about PLC programming. So here what you can do here, just right click on EtherCAT master and select transfer field bus configuration. Once you do that, it will say, okay, there is already a project inside. Should we override that? I would say yes, we do that. So we will delete the project data on ControlX and we will overwrite our configuration. So it is asking that at the moment it is in operational state. To enable the new configuration, we have to switch to initialization. I'm fine with that. Click yes, and now it's done. So you can see that you can verify that configuration. If you go back here, you can see the status is green and this is running. And also the status on my ControlX IO is green, which is perfect. Good sign that everything is working fine. So our ControlX IO configuration is done. Very important to note that here you have to make sure the configuration step is done, and then we come to the PLC programming, which I'm going to show you now. So next part of this video is how to write a PLC program, and we can check the IOs in this PLC program. So before I continue to this step, I want to show you once the configuration is done, ControlX Core can access the data, can access the information via data layer. And this data layer you will find in settings, and then you can go to data layer here, and here you can see there is a field bus folder. This is a field bus, EtherCAT master, and here you can go to EtherCAT, and then you go to master, and then you go to instances. Let me just make it bigger. Again, EtherCAT master, real-time data, input, and here you will find the data for the input. We have a coupler, which is also supplying data, and we have this digital input terminal. Here you can see all the channels. Like I said, it's a 16 channel input, so you can connect 16 inputs, and it will show you the status of all the inputs. Let's see the status of first input. If I select on that, it says it's false. Now if I activate this input from my trainer, let's see if it changes here. So I'm going to go here and turn on my input, and you can see that my status is true. Similarly, you can have status for other channels as well. All right, so channel 1 status and all other channel status you can read in your data layer. All right, why I talked about that? Because we're going to use that in our PLC program. So next step is to write a small program using this I/O inputs and outputs. So in this case, I will go back to my ControlX Core, go to my home page, and I see I have my PLC app already installed. So for that, for PLC, you also need a PLC app. So once PLC app is installed, the license is installed, you can open PLC Engineering. So in this PLC Engineering, you will find how you can write a small code. So let this PLC Engineering opens. It opens here. There is already currently in use a project. I don't want any project. So let's start a new project. And I think another instance of PLC is running. Let me just close this one. So, okay, so PLC Engineering is here. Now we go to new device, new project, and it will ask you for some templates. So I would be happy to use ControlX Core templates because then it will add my controller automatically inside. So using this template, it will add a ControlX Core project core device already here, which is perfect. Otherwise, you have to add manually. Now, in this program, I will write a sample program. So I have to first define some variables. So I'll quickly do that. I will take 3 input variables, IN0, IN1, 3 Boolean variables, IN2. I missed the equivalent sign. And oops, this should be just like this. And then you have out0, also bool, out1, also bool, and out2, also bool. So we have 6 variables defined, 6 Boolean variables, 3 inputs and 3 outputs. I just want to actuate the output with the input, so nothing fancy here. I will just now write my code, which is pretty easy. Out1 is IN1, out2 is IN2. You can write any fancy program you like. This is just for explanation about how to use external IOs. So my output 0 triggered by input 0, output 1 by input 1, output 2 by input 2. Now in this program at the moment, these are just local variables. All right. I want to connect these variables with my external IOs, which we have seen in our last step. So to do that, like I told you, we have data layer in ControlX Core, which is reading the information from the digital input and output terminals. We will use this data layer. So to use this data layer, let me go back to my data layer real time. So I can access the data layer in this real time. Before that, I have to check my communication settings again. So let me just test. Everything works fine. Now to add the data layer, you can right click here and you can say online from ControlX Core. I want to read it because we have configured in the last step. Now here you can see that this data layer is available. It says only for ControlX Core, perfect. Apply changes and you will see 3 more data layers. One is for the coupler, another for digital inputs, and this for digital outputs. So I want to reinsert all the data. So once you click that, it shows here and you can apply changes and close. And now you have 3 data layer nodes which will supply you the data. Now I want to connect my inputs to my input from my digital input terminal. It's very simple. Just double click on that and you will see data layer node IO mapping. Here you can map your inputs. So first input is my IX8.6 and this is my channel 1 value. I want to connect that to my PLC program for IN0. Very simple. Just double click here and select the application, PLC program, IN0, done. Very simple. Data mapping is done. Similarly, I will do for IN1 and IN2. So this was for my input. Now I want to tag my output local variables with my digital output terminal. Similarly, I can do that for data layer node for digital outputs. Channel 1 is QX0.0. This is my output 0, then I have output 1 and output 2. 3 tags are done. Super easy. Now what I can do is I can download this program to check my results. To download, it says PLC is on run mode. Would you like to put it into stop mode? That's fine for me. And now it's generating the code and downloading the logic. It's done. PLC at the moment is at stop mode and my input is true. Let's go to run mode and see what happens. Perfect. My output 0 is true. Now let's check the other inputs and see if I get the status on my PLC code and on my output device. Now I will actuate my output 1. Here it's working fine. It's actuating my output. And then one more time here, I have my third output. It's true. So you can see the status of outputs on digital output terminals on this green LED. And actually I have an output lamp here, which is showing you some colors. So these are my inputs. I can turn it off and I can turn it on however I want. This is actually supplying 24 voltage to my digital input terminal. All right, so this was how you can connect your IOs in the physical and access that in the PLC code. I hope you like this easy way to configure digital IOs in ControlX Core. In the next part is my favorite part. In the next part, we're going to monitor this IOs in our dashboard using Node-RED. And Node-RED is one of my favorite apps which I use for many applications. So I'm going to show you how you can use Node-RED in ControlX Core and read the information about the digital IO terminals and some another important information I'm going to show you in a minute. So let's open our ControlX Core, and you also need to have a Node-RED app which you can buy from ControlX Store. You need to install this app with an appropriate license. And once you have this license and the app, you can just open Node-RED from here and go to Flow Editor. In the Flow Editor, I'm already using some flows and some nodes which is reading the data from my ControlX Core. So if you notice here, I have channel 1 input, and channel 1 input is my digital input. And in this channel 1 input, I have my subscription from ControlX Core. So I have my local host with my username and password, so it's a secure subscription. And this is reading the data from ControlX Core using the path which is my data layer path. So this channel 1 value, if you see here, it's coming from my data layer. So if I go to my settings and again in data layer, I go to field bus, EtherCAT, master, instance, EtherCAT master, real-time data, input, and data. This is my input, and that's my channel 1. So once you select that, you have this whole path here. You can just copy this path and you can paste the path here and click on done. And it will start reading your inputs based on if there is any changes. Similarly, I have channel 2 input, channel 3 input, and 3 outputs. Another interesting part here, what I have is a bus coupler status, which is very important in some diagnostic, to have some diagnostic information. For example, the logic voltage, peripheral voltage, logic current, peripheral current. So the bus coupler supplies some voltage and current to your digital input terminals or output terminals. This you can also read, because in some case, if you're having an over voltage or over current condition, you can log this data with some timestamps if you want to extend your functionality. So I'm showing all this data in a beautiful dashboard, which you can see here now. So here I have my dashboard, which shows the status of channel 1, 2, and 3. And you can see this bus coupler status as well. So if we see this all together, let me just change the status again. I will change the input. I'll make it false. And you can see the status on my dashboard. Channel 1 is false, which also reduces my peripheral current, because now my one load is off, so the current usage has been reduced. So if I turn off my second channel, now in this case you can see that the current has been reduced even more. So the peripheral current has been reduced, which is good because it should not be more than required. And you can see the limits of this currents and voltage in the manual. So I hope you like this video. You have understood how you can configure your ControlX IO and how you can read the data using data layer and how you can use this data layer to read the information in the PLC to make your logic. Furthermore, how you can read this information via data layer on your Node-RED. Using this data layer, you can have multiple possibilities to read the data, log the data, send it to the cloud, however you want. So this was the last part of the video. I hope you enjoyed this video. If you like this video, please like and subscribe. If you subscribe, you will get notification about my next video in ControlX Core, which possibly would be on the IDE control or the Python. This will be really interesting, and there are many more videos coming with ControlX Core, so stay tuned, subscribe, and if you have any doubts or any question, you can put a comment on this video. Otherwise, you can check the forum of ControlX Automation, and there are so many engineers helping you out right away for any queries or questions that you have. So I hope you enjoyed this video, and see you in the next video. Until then, have fun, take care, bye-bye.